Welcome to MOLDEX3D video training series of smart learning technologies. This video training is for everyone who is related to mold design, mold flow analysis protocol, and those are looking for higher end ROI over the plastic mold solutions, and they want to fix lots of issues which you come across during manufacturing, and from concept to your product prototyping, the complete range of issues you can fix and you can have higher ROI. And the MOLDEX 3D is the high-end molding innovation solution for higher ROI. And we have more than 50 projects which we have created for catering to different industry and verticals, which can directly save your time and you can get higher ROI over your mold design solutions. But what I will suggest is you can select any 10 from the range of 50 which can directly resonate to your kind of product design, or you can submit your own product if you don't find within our 50 plus. So that may be automotive, consumer, that may be medical device or whatever. And I am Pramit Kumar Senapati, subject matter consultant and R&D research and development head at this particular organization, and I basically do the complete product concept mapping to and catering to the different solutions which we come across by taking the feedbacks and that we incorporate and create a product like this. And you can follow me through my LinkedIn profile or Facebook. So the agenda is very specific and clear. So let me start with why MOLDEX 3D we have to select. And even honestly, I'm saying we have other product and solutions like Autodesk Mold Flow. That is also one of the best solution. But MOLDEX 3D also is one of the key and industry leading solutions that you can definitely use. And next we'll go to our training solutions and projects and typical solution process. So why MOLDEX 3D? So most of the designers, analysts, and the mold flow analysts people they used to ask me. The simple answer is MOLDEX 3D is the world's leading computer-aided engineering solution. This particular solution can be used for plastic injection molding industry and various different verticals and horizontals you have that I will be discussing. But with the best in class analysis technology, MOLDEX 3D can help you execute your in-depth simulation, and maybe you want to use the top-notch ANSYS solver or Abacus solver or maybe Nastran solver. All this it embedded and it supports and that you can use. And widest range of injection molding real scenario process is embedded so that you can optimize your overall product design and the manufacturability, or the you can launch your product and without going for a lots of trial and error process, and you can have your first prototype success. But primarily, if you look at the three different component, why you'll be going for MOLDEX 3D, I'll be starting with simulate your process. What is your process? Your process is the injection modeling process, and you have to mount all this, and the protocol or the intellectual process which you follow or the domain knowledge which you peer and carry, that also you have to integrate. And encapsulation, that also it supports. And fiber and post plastic injection molding also you can apply, and if this is your process, that also it supports. And gas assisted injection molding also you have the parameters and that you can take care, hot runners and insert molding. And if you talk about the injection compression molding, that also typically it caters and you have the solution. And if you see microcellular injection molding, that is one of the new you can say the process that also it supports, and in the recent updates you can use this particular benefit. And reactive injection molding, and the variotherm. And variotherm also one of the important molding design process that you can use, and water assisted injection molding if you are using, no problem. And investment casting, that also solutions you can use. And most of the people they think okay, this is only injection molding, but you have so many niche and you have so many different horizontals, and that you need to understand and before selecting a solution. And the conformal cooling. And next we'll go to the working with leading CAD package. So ACIC, the ACIS kernel is basically for transforming, and the parasolid also for transforming into your MOLDEX3D, and you can interexchange between CATIA V4, V5, and Creo Pro E, the Inventor, NX, or UG any earlier versions, and SolidWorks. So seamlessly you can integrate with different heterogeneous data, or you can say different extension. And one of the important aspect is used in major industries and automotives, consumer product. It caters from toys, the shampoos, or whatever the product you use on daily basis. All the packaging, you are going for MP3 player, it's complete plastic package. You are going for headphone, you are going for cell phones, electronics, medical device, and optics. That may be specs, that may be different optics instrument, that all it caters. And next we'll look into our training solution and projects. As I personally believe that a ready-made solution process is just waste of your time. So what we have done is we have completely collected from different industry verticals, lots of projects, and we speak one-to-one to our customer, and then we map their typical issues or projects as a solution protocol here, and then we deliver. But in fact, what I want to convey here is mostly 75% of the designers prefer exact understanding of feeling. That may be word line problems, that may be the wrappage, that may be any process which may arise, and that issues you need to fix before starting your injection process, before switching on your machine, injection machine. So how to do that? So what we have done is we have documented different projects, and that may be your pocket, and that may be a typical remote system, or that may be a typical a plastic and with different contours and complex process. And you can see this. And typically, if you talk about the automotive panels and all, we have a variety of solutions. So just you say your industry will give you solution. And if you talk about the water bottle, there, if you talk about a different complex or semi-medium to complex bottling system that we have in our projects. So we have a range of 100 projects, but typically I'm showing here some uh, important 50 projects that you can refer, and you can select any 10 when you go through our training process. And this may be very useful, maybe the USB and the charging system, that plastic complete system. And this again another device of the charging system, and the connected device with different branding when you want to locally create these products. So you have to engineer the product and understand the ROI. And next you can see the typical other projects where the complexity involved and the type of the complete filling process which you do. So provided you have already done the core and cavity, and then you're going for the filling analysis and its complete protocol, and maybe the tray system, plastic trays, and maybe this type, and maybe this type, and maybe shopping cart which you use in different shopping malls, and maybe this is the bottle holding device, this, maybe this. So maybe you are using inside a particular machines, and there you are covering, and maybe a tray system, maybe the side support system, whatever. So we need to understand how the particular project can be used in your industry. And there is a bullet system where you can case inside the casing, and this is a tray system where you keep your visiting card, and this again a emergency light system and complete plastic system here, and here also again the electrical connector and its complete process, and this is the door handle, again the plastic fan blade, and the typical filling process when you talk about in any project. And not only the filling process, what you can do here is you can optimize the overall location of the gate where it is performing better and filling time is optimized, and as well as you can go for typical case study. You want to try three different gate location, and primarily if you go for that in the real without having a virtual simulation, you just waste your time and money and everything. So what you can do is you can go for a case study in three different scenario where I'm getting the best result, and that I can map. And like that, this is the fender automotive two wheelers fender system front or the back fender, there is the back, so that you can create. And there is the shoe, you can say the shoemaker, it's a complete process. And this is the garden chair, that, and again you have different type of example I have taken. This is a spray system maybe for cleaning, and that complete injection process and the filling optimization that you can check through this project. And this is the hair dryer, you can see the hair dryer, and you can go for the optimized process, or maybe two to three different locations you can see, maybe a round or maybe a hexagon or maybe a square, different type of gate you can check, and injection process you can check and optimize it. So we have considered a couple of different projects which may resonate, and if you don't have, then you can go for this is basically ice cream bowl, and this is again basket and its complete system. So that may be complex, semi-complex, and simple, but overall process you have to understand, and then you have to understand and apply that same concept, because all the projects are not like the same. So each project cater to a typical case scenario and inputs, and that you have to understand. And there is a satellite device, and for that, so like that different projects we have the ice trays, and this is a typical device which you can see a plastic component, and this again you use for the cleaning your bathrooms or toilets or kitchen. So those device, this is the mouse which you use on your computer PCs, and this is typically MP3 player and its overall package here. So this complete, the prototype before creating this, and the complete ergonomic and fitting that you can do before, and the filling analysis for this. And this again a shopping cart, again another electrical assembly unit, and this is the chair which you use. Again this is the fancy item, you can write keep your pens, pencils and other device over your desktop. And this again a typical component. So like this variety of projects we have, you can select the right kind of projects that directly can cater to your industry, and if you don't find, then we can customize and send one for you, or maybe up to 10 numbers for you, and directly you can apply that, and you can get this is a basically typical packaging of a shampoo, and you can see this is twisted, and this typical packaging they are taking. And this again the sitting chair, this is the telephone, and this is the Tupperware typical food storage device, and this again another connector unit. So like this you have a variety of projects, and where you can address and understand and map the process. So typical solution process, so if you see the typical solution process, then I will show you that how this works in your Moldex 3D. So once you import your geometry and build your complete runner system, and then you specify your cooling system, then you generate the mesh or convert this into finite element analysis protocol. That is, you have your model, CAD model, that you mesh it and convert to finite element model. Then you export those mesh for analysis. That means before post processing you have to submit to your solver, and then you select your analysis type of analysis. You set your typical material, it the process and computation parameter, and finally you set analysis sequence, and then you execute your analysis. Then final process is the post processing, where you get your results, and then you go through those results and generate the report or a customized type which you are looking for. So let me show you this directly. As we have gone through the whole process of your complete analysis, and in MOLDEX 3D, the R13, which is the recent release of 2015, and here what we can do is you can see the overall process of the sprue, riser, runner, and gate system, and this is the component. So during analysis, you can go for the filling, packaging, wrappage, and various other type of analysis. In case of filling, if you go for the melt, front time, and this particular diagnosis, or maybe the gate contribution, this you can see the gates typical contribution, you can see the 71.63, and gate 2 you can see the percentage. So this split is very essential so that you can optimize and you can distribute and adjust the whole process. And the overall pressure, that you can see the megapascal 81 from the higher value to this, and with the color node you can see the higher pressure is coming through this, and once this touches this particular gate, then what happens, you can see this particular tone. That means you are going, and the least number of pressure you are getting this particular area. So wherever you have the filling issues or problem, you can reallocate, or maybe the changing the diameter, maybe the typical materials density. So all this protocol you can fix here. The temperature distributions, the overall, and the average temperature. This protocol bulk temperature is basically the ambient condition specific, and the mass flow rate, and you can see this G per second, and the maximum wear and minimum wear, you can see the is overall probably it is equal distributed, but still some areas that you can plot and that you can fix it. The volumetric shrinkage, that you also you can see the percentage, the maximum shrinkage you are getting the 5, nearly 5.8% over these areas, and the least values, and the shear stress, and the shear rate. The density protocol is very important, that you can see the distribution 1 0.05 to 1.118 where it is maximum, and then the melt uh, front temperature and the velocity vectors, and that particular vectors you can directly see from the legend and you can get it. So in our complete training solutions we have discussed each and every point and explained why and how you have to control those. And if you go for the packaging, here the gate contribution also you can see, and the pressure and all these property which I have shown accordingly you can get. And also you can see the sprue pressure, and here you can see the typical sprue pressure curve and flow rate curve. And this is very important for the management people, or maybe the top tier people, those are directly assigned with the ROI and the volume fraction, this curve. And you can customize also, you can add new curves also, field volume, this, and the melt front node, this. Primarily with respect to this you can directly capture this and create the animation and weight reduction, and you can change your custom setting and do that. And in case of the raw page, what you can do here is the displacement along each direction, you can get the maximum to minimum in mm unit, or the total overall displacement you can see 1.7 mm displacement, and the least value is this, and the legend. And like that, the thermal and other properties and the sink mass and PVT displacement, those protocol also directly you can have. But specifically the primary intention is this just the analysis. But arranging the gates, riser, runner, its typical dimension, and go for a 3 to 4 case study and optimize one and then implement for your prototype is the key. And that is different for each and every project. You don't have a common algorithm which will fix and apply to all the project. This is very specific to projects, and that you have to understand. And then when you apply this directly, you have the typical post processing. And if you see the post processing graphics, the typical material and the mesh that you can customize. And as far as your material is concerned, if you see the typical material and its typical graph and the PVT, the heat capacity, thermal capacity, and viscoelastic and mechanical properties that typically you can get from the bank, or you can create it, and you can get and capture this also, and you can directly compare the with other material, and then you can see how it is technically influencing, and then you can really decide and a bunch of material why you are going for, and maybe a little bit deviation with the property that can justify technically. Thank you.